Right, so in this question I have an incredible amount of information given to me, and what I'm going to do to start with is just work that information down into a different format. So I'm going to write down here S, U, V, A and T, and I'm going to analyse each section of my journey independently. So a car starts from rest, initial speed 0, moves with constant acceleration and reaches a speed of V. So my final speed here is V, and it takes 20 seconds to do that. It then moves with a constant speed of v, so for my next section of my journey my initial speed and my final speed are the same, there's no acceleration, and I'm told that that takes 30 seconds. In the next section of my journey I'm looking at some deceleration. I'm decelerating by minus a half, so my speed was initially v, and I'm decelerating down until I reach 8 meters per second. I'm not sure how long that takes. In the next part of my journey I'm moving with a speed of 8 meters per second for the next 15 seconds. So again, that's a constant velocity, so that's 8, no acceleration because it's constant velocity, and my time here is 15 seconds. And then in the final section here, starting from a speed of 8, I'm decelerating again, this time by minus a third, and I'm reaching rest, so that's going to be 0, and again I don't know how long this takes. Now that's quite useful because I can use this information then to draw my graph. So let's just set up our axes for this. And what have we got? So first section, we've got constant acceleration, so we're starting from 0 and we're heading up to a max speed of v, and this time is going to take 20 seconds. Next part of our journey we're travelling at a constant speed. Now I need to make sure that physically this section here, which is 30 seconds, obviously looks longer than my initial section, which was only 20 seconds. So this is 30 seconds in length, add that to the 20 and end up here with 50. I'm decelerating for my next part until I get down to a speed of 8, so let's indicate that here. Don't know how long that takes. And then I'm travelling at a constant speed of 8 for 15 seconds. Again, let's try and make that look realistic compared to my 30 and my 20. So let's put that in there as 15. And then finally I'm decelerating at minus a third. Now bear in mind that my deceleration here was minus a half, which is magnitude wise is greater than a third, so the gradient for the half should be greater than my gradient at this point. So let's just try and make that look a little shallower. There we go. And that's it, that's my graph set up. I should probably label on here that this is v in meters per second and this is t in seconds. The next part of this question, I'm told some additional information. In the first 20 seconds of the journey the car travels 140 meters. Let's add that information to my diagram because I know that the area underneath the displacement time graph is going to give me the distance. So this is 140 meters, and looking at this shape I've got a triangle, so I can just do some basic area arithmetic. So I can do the base, which is 20, times by the height, which is v, divided by 2 is going to give me 140. So 20v is going to give me 280, and dividing by 20 I find out that v must be equal to 14. So there's my value for v, it's 14 meters per second. So let's just fill that in on the side here. Great. Next up, total time for this journey. Okay, this is where, again, it really helps for me to have this information in this format. So let's just go through here and fill in the v's, which I know are 14. And what can we say? Well, in working out the total time, I need to know what the two times are in these gaps. And I can nicely work those out because I know a nice little Suvat formula of v is equal to u plus a t. So substituting in the values for the first section, this final speed is 8, the initial speed is 14, and the acceleration was minus a half. Subtracting 14 from both sides, I've got minus 6 is equal to minus a half t. Multiplying through by negative 2 tells me that 12 is equal to t. So this section here is going to take me 12 seconds. And doing the same for the second part, again using v is equal to u plus a t, I can substitute in my values here. So 0 is equal to 8 plus minus a third times by t, again subtracting the 8 from both sides, and multiplying through by negative 3 tells me that t must be 24. 4. Now it's just a case of popping these numbers into my calculator, and I think we'll find that they will add up to 101. So there we have our answer for the next part, which is 101 seconds. The final part of this question requires me to calculate the distance travelled. So again, let's go back to our graph for this, because we know if we can calculate the area under this graph, then we'll be finding the total area, the total distance travelled, sorry. We've already got the 140 metres for the first section. The next part is nice and straightforward, because I can just do 30 multiplied by 14, which gives me 420 metres. Again, this section in here is nice and straightforward. Another rectangular section, 15 multiplied by 8 gives me 120. We know now the various times that we had, so that the distance between here and here was an extra 12, and the distance at the end was 24. So this is going to allow me to calculate the area of the triangle. So I know the base is 24 and the height is 8, so I want to do 24 multiplied by 8 divided by 2, which is going to give me 96, so my area in here is 96 metres. Let's make sure we're being consistent. And then finally I've got a trapezium here that I'm going to need to find the area of. So this is going to be 14 plus 8 divided by 2, half the sum of the parallel sides, multiplied by the gap between them, which is 12, and that is going to give me 132 metres. Now that I've got the individual sections, I can just add these together, and I'm going to get 908. So my final answer in here is 908 metres. So really key to solving this question was, when I was reading through my initial information, finding a nice format to write it in. And really, this table that I've set out from the start has helped me a number of times, and it really clearly shows the examiner that I understand all the information that's come from the question.